Now we will look at solutions and solubility. So solution is a homogeneous mixture where everything is in the same phase. So they're all solid, all liquid, or all gas. So for example, iron is a solution of all solid. The air we breathe would be a solution of all gas, and salt water would be a solution of liquid. So we have a substance present in a greater amount, and that's called your solvent. And we have a substance present in a lesser amount, and that's called your solute. So if we have 2 grams of salt in 3 liters, which would be about 300 grams of water, which one is your solvent and which one is your solute? So your solvent is going to be the water because it's in a greater amount, and your solute will be your salt. The concentrations tell us how much solute is present per amount of solution. As chemists, we like to report this as molarity. Molarity is the moles of a solute in 1 liter of solution. So what is a mole? It's atoms. Atoms are too small to see, and they're way below what you'd be able to work with in the lab until you're working with billions of them. So we talk about them on a level of what we would be able to see, which is about 6.02 times 10 to the 23rd of the atoms. And once you get up there, then you're getting in the vicinity of what we actually measure out in the lab. 1 mole of sugar is about 1 cup of sugar. 1 mole of water weighs about 18 grams. Around a mole of something is big enough to see and work within the lab. So we report them in units of 6.02 times 10 to the 23rd. An unsaturated solution, you could still add more and it would dissolve. A saturated solution, it has as much of the solid as you can dissolve. So you've probably run into this before. If you've had a sore throat, you make yourself some salt water to gargle. If you add a certain amount and stir it in, it keeps going in. You add a little more, it just keeps going in. If you add too much, you end up with sludge on the bottom. So that solution there is oversaturated and it's no longer dissolving. Solubility is the ability of your solute to dissolve in the solvent. So if any large amount of solute is able to dissolve, then it's called soluble. So salt water works, sugar water works. If the solute doesn't really have a limit to how much you can put in, you can just keep adding it until it becomes the solvent itself because it's in a greater amount, then it's called infinite solubility. So if you add ethanol to water, just a little bit stirs in. If you just keep adding ethanol, it just keeps stirring in. So we are able to have an infinite solubility there. Oxygen and nitrogen gas, we can keep adding oxygen, it just keeps mixing in. So that's infinitely soluble. If the solute doesn't go in very much, it's called insoluble. So I can take oil and water and I can kind of stir it really fast and get them to mix together temporarily, but then most of it separates out again. That's an example of something that's going to be insoluble. They don't mix very well. They don't have enough molecular attractions between them to overcome the differences in what they are. Temperature affects your solubility. When you increase your temperature, solids tend to dissolve more. When you increase your temperature, gases tend to dissolve less. So let's talk about why this is. A solid, you'll remember, is like your apartment rooms. Those molecules have their little space. As you add heat to that solid, they shake more and more in their apartment rooms. And if you add them to something that can dissolve them, they already have plenty of energy to separate out from the rest of the solid atoms that are there and dissolve in solution. So heat helps. So if you've taken and made salt water, you usually make hot salt water because more salt will go in. If you have a gas, gases can already move really well. They move better than liquids. And if they're in that liquid and you're adding heat to them, then they shake and move all the more, and they're more likely to just shoot right out of that solution. So you want to slow down the movement, cool them down to keep them trapped between liquid molecules. So this is why it's best to keep your soda can in the fridge once you've opened it, because when it's in the fridge, it's cool. The carbonation is less likely to escape.